All right, week 2, June 29th to July 5th, new NEW 11. We are still working on systems, but we're going to take it one step further. We're actually still graphing, but the one step further we are going to take it is by graphing equations to find where they intersect when they are not solved for y. So again, this is kind of putting together things that we've already done. We're going to graph equations in the form of y equals mx plus b, but the step we're going to have to do before graphing them from y equals mx plus b is putting them in the form y equals mx plus b. So they're not going to look like that beforehand. So we did that last week. We solved for y, we got y alone, and that is what we're going to do in this section. So let's get started. For number 1, we are going to do that setup problem. We're going to make sure we know what is a solution for a linear system or for a system of equations. So if we look here, this is a system. A system can be any number of equations. We're going to look at systems that are 2 equations. So when we have 2 equations, we have 2 variables, an x and a y. In order to be a solution, an ordered pair, x comma y, has to work in both. So we're going to create our template for this. So 2 parentheses minus parentheses equals 10. And my other equation is parentheses minus 5 parentheses equals 20. So all I've done is I've pulled out the x's, which I'm going to highlight where they go, and I've pulled out the y's, and I'm going to highlight where they go. And then I am going to plug in the x and the y in each of the places where they belong in our equation. So every time I see or I saw an x, I'm going to replace it with a -1. And each time I saw a y, I'm going to replace it with a 3. So in this first equation, I have 2 times -1 minus 3 equals 10. I'm going to draw my river, and that gives me -2 minus 3 equals 10. So working on the left side, I have -2 minus 3. That gets me -5. -5 does not equal -10. So I know this ordered pair is not a solution. I don't even actually have to go to the second equation because I'm done. I know it's not a solution. In order to be a solution to the ordered pair, that ordered pair has to work in both equations. So I am done. Now, if I wanted to test it and see, I could come over here and I could say -1 minus 15 equals 20. That actually equals -16, which -16 doesn't equal 20 either. So that ordered pair doesn't work in either equation. So I would know that this ordered pair does not work for either equation in the system. But unless it works for both equations, you know you are good to go with it not being a solution. All right, so if we look at number 2 down here at the bottom, all right, we're graphing the system. So graphing the system just means we have to get both of those equations onto our coordinate plane. So if we look at this first equation, this is actually one of our special cases. All right, and with our special cases, we have 2 questions, if you remember. All right, and the questions that we need to ask ourselves is what axis does it go through? And where, right? So, or what number? So in this one, what axis does it go through? It goes through the x, and where? At -2. So if it goes through the x at -2, it looks like a straight vertical line at -2, right? What axis does it go through? It goes through the x at -2. So remember, sometimes our special cases, they can kind of catch us. Not that they're more confusing, but they don't follow the same rules as all of our other ones. So we just have to remember what rules they do follow. So what axis does it go through? It cuts through the x-axis, and it happens at -2. So it looks like a vertical line at -2. All right, now our second equation, we need to get it in the form y equals mx plus b, so that we can go ahead and graph it using, the y-intercept, where does it begin, and then our rise over run. So we need to get y alone. So we need to get this y by itself. And the way I do that is I'm going to divide everything by -2. Okay, so when I do that, these -2's divide out to be 1, and I get y equals. Now, in front of that x, I really have a 1, because remember, for slope, I want those two numbers. I want that fraction number. That's going to help us. So I'm going to have 1 over -2, and then an x. And then -4 divided by -2 gives me +2. Okay, so I'm just going to rewrite this down here so that I don't have a line in it, and it's, nice, and so that I can highlight and all that. I have y equals, and again, your negative, it doesn't matter where it goes. I usually float it to the top, but again, it does not matter. So -1 over 2x plus 2. Remember, your negative can either be on the top or the bottom, but it cannot be in both places. So we're talking slope and y-intercept. Okay. Oops, somehow I got... Here is my B, where I begin. This is my up, down. So I am 2 up because it's positive. This is my M. This is my rise over my run. So I am down 1, right 2. Now, say I kept, with that one, where my negative was on the bottom, this could also be up 1, left 2, right? I can have it either way. So let's look at that graph. So I'm up 2, right here, up 2. I'm starting right here, and then I'm going to go down 1, right 2. Down 1, right 2. And you can see, again, we talked about this last video, if I'm, going away from my line, I want my lines to intersect. So if I'm going away from it, I need to go the other way. So this up 1, left 2 is what I want to be doing. So up 1, left 2. And there we go. That's my point of intersection. So you see right here is where they intersect, because if I connect my dots here, okay, you see that's my point of intersection. And if I write it as an ordered pair, as an x and a y. That is -2, left, right, and then up, 1, 2, 3. Okay, my ordered pair is -2, 3. So my ordered pair answer is -2, 3. All right, let's go on to the next one. All right, so I'm going to do all my work to get my y alone before I even start looking for my my slope or my b. All right, so I need to get y by itself. So here's my y. Here's what I need to get by itself. So I draw my river. Okay, I need to subtract 3x from here. I subtract 3x from here and I scoot it out because these are not like terms. Those zero out, I get -2y equals -4 minus 3x. I divide all three by -2y. Just -2. So when we divide everything by -2, these divide out to be just a y equals negative divided by a negative gives me a positive. 4 divided by 2 gives me a 2. Again, negative divided by a negative gives me a positive. We're going to leave this fraction. Now, this is where we talked about last week. Dividing out this fraction to be a decimal does not help us because we need that rise over the run. The decimal is not going to help us to graph, so we're just going to leave this fraction alone. 3 over 2, we're going to leave as 3 over 2, and we're going to pop out that x to be an x right after the fraction. Now, the only problem with this on the right side is that, excuse me, technically it's not in y equals mx plus b. We really want it to look like this, y equals mx plus b, meaning this mx is first, this plus b, the added or subtracted on kind of third wheel component, is at the end. So when I rewrite this, I am going to rewrite this y equals, and if I look at it kind of highlighted, right, this piece needs to go first. This piece needs to go second, and our signs need to stick with us. So it's this positive 3 over 2x that needs to go first, and it's this 2 that needs to go at the end, but we need a sign that needs to come with us because it's added or subtracted onto the end. Because it's added or subtracted onto the end and there's nothing here, it's added, okay? If it were subtracted on, there would be a negative there, but it needs to be something because if you put no sign there, it looks like it's multiplied. So that's kind of it. It's a little chaotic there with all the arrows, but that's it. Now we're done. We can move on to this next one. All right, so solving this next one for y, drawing our river, adding 9x to both sides. When we add the 9x to both sides, we scoot it out on the right side because those are not like terms on the right side. These zero out. I get 6y equals -9 plus 9x. I divide everything by 6. The 6's divide out to be 1 on the left, so I get y equals. And then this is not a nice one. So I get -9 over 6. We're going to leave that for a second. And then over here we get plus 9 over 6x. I pop my x out. I don't like to keep my x in the numerator just because sometimes it gets lost there. Now, 9 over 6 ends up being, when it simplifies, I can take a 3 out of both of those. I can divide out a 3. So I get y equals negative 3 over 2 plus 3 over 2x. I'm going to scoot them around. I'm going to switch sides. So I get y equals, this one is a positive, so 3 over 2x. And this one is a minus 3 over 2. Now, for this one, I need it to be a fraction because it's my rise over my run. But this one, I need, it's my y-intercept, okay? So that one can be a decimal. So I can think about that as 1.5, or in this case, negative 1.5. All right, so let's look at what happens here. I'm graphing. So now I have my two things that I need to graph. So here, what am I graphing? My intercept here and my slope, my rise over run is there. Here, my intercept is this or this, and my rise over run is this. What do you notice about your slopes? Your slopes are actually the same, right? Your slope in your first one here is 3 over 2, and your slope here is 3 over 2. So we're going to see in a minute what that means, but just things we're noticing. All right, so graphing your first line. This B is equal to 2. That means we're up 2. My rise over run is 3 over 2. So we're going up 2. We're marking our dot. And then we're rising 3 and we're running 2. So up 3, run 2. And I actually can't do it again because I run out of room. But now I can fall 3 and run backwards 2. I can do that again. I can fall 3 more and run backwards 2. So now I get this nice line that looks something like this. All right, what about this one? Now, this is my y-intercept, my B. It's negative 1.5. Okay, which means that I'm coming down and I'm right in between 1 and 2, negative. And my rise over my run is still this 3 over 2, right? So, yeah, it's a little confusing because I'm in between boxes, but I'm going to follow the same theory. I'm going to count my boxes, 3 up, and I'm going to run 2. So up 3, 1, 2, 3, run 2, 1, 2. And again, I'm still in between boxes because I started in between boxes, so I'm going to end in between boxes. And I can do it again. 1, 2, 3, 1, 2. And I could do that falling as well. 1, 2, 3, 1, 2. What do you notice when your slopes are the same? What's going to be true of your lines? Will they ever intersect? The answer is no. So you will never have that point of intersection. When your slopes are the same, you will actually have a situation where you have no solution. All right, so slopes being the same will give you a situation where you have no solution. All right, so slopes, when your slopes are the same, that will give you no solution. Definitely something worthy to note. And now that you've taken one of my quizzes on like new material, you'll see like that could be a good question, because here's the reality of the situation. And this was going to come up in our live anyway. There are a lot of math apps out there that do the math for you. And listen, this is not me standing on my soapbox saying you're out there downloading the latest app that can do the math for you, okay? This is not like an accusation. But the reality is sometimes being able to explain something, being able to make that connection, being able to answer that theoretical question says that you understand more of the math than being able to do that problem, right? So you being able to answer that question on the quiz where you say, when you have the same slopes, you have a problem that has no solution, that's a very valid quiz question, okay? There also might be a situation where I ask you to upload, your work. We are living in the digital age. We are living in an age where now, a lot of it's like submitted online. A lot of it is multiple choice questions because that's what's graded, instantaneously. But that's not the reality of if you were sitting in my class, what would be getting graded? Or what would be being looked at? So there's lots of different ways to be assessed. And that's just kind of the reality of the situation. All right, let's look at number 4. So again, getting y alone. We're looking at the first equation, drawing our river. We want to get this y alone, okay? We need to be moving the, highlighter mode. We need to be getting the 2x to the other side, so we're going to subtract it from both sides. It zeroes out on the left. We pull down our y. We get 2 minus 2x on the other side. We're loving it because y is already alone, but now they're just in the wrong order on the other side. We want y equals mx plus b. So now we just switch the order. So we have y equals negative 2x plus 2. Our m is negative 2. We throw it over a 1 because we always want our m, or our slope, to be a fraction. So that's our rise over our run. And our b is just positive 2. And we are ready to go with that one. Let's do it for our second one. I'm highlighting my y, which in this case is actually a negative y, which is going to pose a problem because we don't want negative y. We're going to subtract an x from both sides. We scoot it out on the right. It zeroes out on the left. We pull down the negative y equals 4 minus x. Now, it's negative y, so I'm going to divide everything by negative 1. The negative and the negative 1 on the left cancel out or divide to be 1. So I get y equals. Now 4 divided by negative 1 gets me negative 4. Anytime I divide by a negative 1, I'm just switching the sign. So if it's positive, now it's negative. If it was negative, now it's positive. Negative x divided by negative 1 gives me a positive. So I have plus x. And now I need to switch things up. So I have y equals x minus 4. Now, I don't like when I just have an x because I have no sense of what my slope is, because I like my slope as a number in front of my x. So I'm going to put a 1 over 1 in front of my x, because not only do I like a number there, but I like a fraction there. So I have a 1 and I throw it over a 1 over 1. So that's my m, that's my rise over run, and that's 1 over 1. And then -4 is my b, which really means I'm down 4. And now I'm ready to go. Now I'm ready to graph. So if I graph this first one, I have +2 and then down 2 over 1. So I'm starting up 2, and then I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And if I wanted to go up 2, I could go back 1, up 2, back 1, and now I've pretty much run out of graph paper. For this other one, for the second one, I have down 4, and then I have my rise over run as 1 over 1. So I'm starting down 4, and then I have up 1 over 1, up 1 over 1, and there it is. There's my point that intersects. I can add a few more points if I wanted to get a nice long line out of this. And you can see I have these nice lines. I can throw arrows on the end, but ultimately I'm really looking for this point of intersection as an x and a y. And in this case, it's 2 to the right, down 2, so 2, -2. And I'm all done.